So let's get back to our functions. So last time we started putting together so-called Monte Carlo simulation of number pi. And the whole idea is that we're going to throw numbers randomly into a square from -1 to 1 and -1 to 1 in both directions. And then I'm going to create a certain number of points in that square. And I'm going to test how many fell into a circle of radius 1 within. And then if I really throw in a large number of points probabilistically, okay, the number of those points, when I divide it by the total number, so the fraction of those points that actually fall into the circle, is proportional to the ratio of the area of the circle versus the area of the entire thing, right? So those type of simulations, that's one way to find an area of an object. Now, for circle, it's great because for circle, I don't need Monte Carlo simulation to find the area of a circle, right? But for some more complex object, that's a pretty good shortcut when you don't have an analytical formula for something. But here we're actually going to take a different turn and say, okay, we know the analytical formula, and this analytical formula has this magical number pi inside, which, well, we know, but it's sort of like a difficult number to pinpoint, right? So it would be actually one way to estimate that number. Okay, so let's do that. So step 1, so whenever you have a little project like that, you kind of work in steps. So step 1 will be create endpoints within this circle and count how many fall inside. We also want to plot it. That's a way to both visually understand the problem and also debug if there are any issues. Okay. And I want you to do different marks for the ones within the circle and then estimate this pi. So how far did you all get on Friday? I first actually, not far at all. It was Friday, Dr. Bogdanovich. What kind of stupid questions are you asking? So there's number of points. I'm just going to do 20 for initial testing, but the idea is that we want to program in a way that this can be changed. So if I wanted to create a random number, which function would I use to just pull a random number? Random.rand. And that would be in which range by default? The size of that number is? Random. Between 0 and 1. The size is random between 0 and 1. Smarty pants. Okay? So Smarty pants here says it's a random number because hopefully as I put a lot of them together, they will cover this entire range pretty well because supposedly they're random. Okay? But they're going to be 0 to 1. So in order to scale them to -1 to 1, okay, I'm going to take this output np random.rand. So I'm going to take 20 numbers, but not 20. I'm going to replace it with n, so I have, so this changes as I change n on top. And then I'm going to do -1 plus 2 times. And 2 times is basically between -1 and 1. It's 1 minus -1. It's the size of this interval. Great, so I'm actually going to repeat the same for y. So now I have the points, right? Now, how am I going to test that these points are inside the circle? What is the test for a circle of radius 1 centered at 0, 0? Geometrically, what describes that circle geometrically? Which equation? Something squared, yes?
R squared.
R squared is 1. What is R? Radius. How do I get it from x and y? X squared plus y squared. Pythagoras would turn around in his grave. All right, so the engineers of 21st century have trouble remembering. All right, so I'm gonna literally say if x squared plus y squared is less than or equal to 1. So it's exactly equal to 1 is circle, less than that is within or enclosed by the circle. Then what? What am I trying to do? I'm going to try to count them. So let's call them S, since S is my summation. So I'm going to start with 0 and I'm literally just going to increase. S is S plus 1. Yes?
Would you do 0, n for I in range, 0, n?
Either way, so if I don't put it, 0 is implied. So I can use it both ways. So this is the same thing. I can do this or I can do range of n. So right now, I'm just going to print S and say points within circle. So let's just briefly quick whether this works. Maybe I quickly see whether this works. Maybe I made some mistakes. Maybe I didn't. Let's see. 12 points within circle. Is that correct? I don't know until I plot. Okay? Yeah, right. Let's plot. What do I need to do to plot these?
Import matplotlib.
I need to import matplotlib. Then what?
And then import matplotlib.
Is that all?
PLT. Now, is that the same thing as just doing import matplotlib?
So I can just import matplotlib.pyplot, but then I don't have the shortcut PLT. So every function I want to call, like function plot, I have to call it matplotlib.pyplot.plot. Okay? Which is why it says, hey, call it PLT for short. Okay? Same as NumPy. Import NumPy as NP. If you just say import NumPy, then you can actually, I think, refer to them just by their name, but then you don't know that they actually belong to NumPy, which has its drawbacks. Okay? So you want to give it something short, like a very short last name that you're going to call it by, because you still have to import things and make sure that you know that this is the function from matplotlib.pyplot. All right. So here I'm actually going to plot it also, okay? So I'm going to actually say plt.plot x of y, y of y. And these inside the circle, what kind of mark do you want?
Blue cross.
Blue cross? Sure. And here I would actually like to put else. I'm going to plot them with some other mark. Yes? So far in the previous test I didn't do anything for else, but now I actually just want to visually see red circle, you say? Okay. So let's give it a shot. We didn't create figure before going in. Okay? That should work fine. If not, we're going to fix it on the fly.
The points changed.
Hmm?
Because it's random.
Okay.
It's random, so
Every
it's like
time
every
she-
time it's going to execute ever so slightly differently. We could fix that, but here we don't want to actually. Now, does this look right?
No.
Maybe, maybe not. It's a little difficult to see. Partly because the plot is not scaled and I have way too little number points. So this is, we're gonna go and push it to 200. And I believe actually,
400.
is it PLT plot.scaled?
Axis. PLT.axis.
Axis.
Scale.
Let's give it a shot. So now it's slightly differently executed, okay? It seems that these outsides ones in red, but there's so small number of points that my statistics is hard to gauge. So we're gonna actually now go and see with larger number of points. So I'm just gonna add a 0. And this is the beauty of programming. I have already programmed it that it takes any n. Okay? So let's give it a shot for 200.
It's a lot.
Now this looks more circular now. Yeah? So as you push, you can now play with pushing. Okay? This is going to get better. Now, engineers in the room are going to actually estimate pi from this. So my assumption is that S divided by N is the ratio of the areas is equal to ratio R squared. R is here 1 times pi. And I'm going to call this pi estimate, EST. Divided by what's the area of this square? Minus 1 to 1 sizes times is, wow, it is Monday. Okay, so my pi estimate is 4 times S over N. Let's see how I'm gonna do that in a, so print, just to quickly gauge it. .06, not too bad. I'm trying to get at 3.14 and so forth. Now here's your introduction to the next lecture, which is about errors. So I'm gonna say, hey, this pi estimate is 4 times S. The error is pi estimate minus, we can take np.pi, which is stored as a true value that we're trying to get to. There's an absolute value. I'm going to go with np.absolute. I think there's multiple versions of absolute values, so watch out. So that's going to be my error. And error, it's always a good idea to scale it, to see the relative error with respect to the size of the number you're trying to estimate. So I'm going to divide it with n pi. Do you all prefer fractions or percentages? Percentages, okay, 100 times. Yes? So then I'm going to do a little report. Estimate pi is pi estimate and error is error. 7% for only 200 points. Not too bad.
What do you need parentheses around?
You can do whatever parentheses you want to make this prettier. I'm gonna be lazy. Now, so as I move, and you can see that every time I execute this, it's gonna be ever so slightly different number, right? Now I want to, so I actually have everything here that I need in terms of the assignment I wanted to get. Now I want to package this into a function that I can execute just to say Monte Carlo pi and just maybe give it the number of points. Okay? So this is your assignment. Take this code and give me a function Monte Carlo pi that takes n as input from the user and returns estimate and error back. It's all in here. You just have to repackage it. So I want a function called Monte Carlo pi, okay, that will take input, we already wrote it last time, input n, count number points, and it will give me output this estimate and error that we just computed. Okay. I want a standalone function. Just a quick review of what you need to do for functions. Let me get to my... So basically, quick review of functions. You have to use def, as a keyword to declare a function. Okay. Then you give it a name. Any inputs, these are input variables. This time we want n to be input. And then the mandatory column. After that, there is a block that will be executed for every input n. And you will finish by returning whatever outputs. Here there's one, there can be two, then you just put comma in between them. So package the code that we have just done as a function. And I will do that too, but you have the code that you're going to package. So I'm going to disconnect the viewing station here, but I'm going to keep recording the video.
Can we call it Monte Carlo something?
However you want to call it. That's just a name. Monte Carlo pi is my suggestion, but you can do whatever you want to do.
certain number you want n to be?
No, it's a function. It could be any number. It's an input. So you're not specifying n.
How did you do that?
Inside the function, it's input. Everything in the function depends on that input n. You're not specifying n inside the function. And then function will execute for every n. You don't get it.
No, the error, the percent, the error in percent. So like this says, the error is 0.001%.
Right. And yours, so what is your behind? You just have print error. So yours is 1.45%. You just didn't print it nicely. And you can't do this in return. In return, you're returning the numbers. Your print is just error. So you printed the error, it's 1.45. You're formatting printout in return. Return returns things, it doesn't print anything. And you do need return. You want to return those numbers. Return. And you return only phi underscore estimate and error without any kind of expected that. Now you want the pretty printout to work with the print function, not the return. So error equals C, error comma percent. So comma and then whatever inside, including a percent.
For I range.
You create another variable and then make it hint.
Yes.
Also print, right?
String.
Right, let me connect back. So all I did is I defined Monte Carlo pi. I decided to go with this name. N is now input. I have to be very careful to remove n from inside the code because that's going to overwrite whatever I write. Okay? So you don't want, you could do that. It's legal as far as syntax goes, but that's going to overwrite input. And then we're going to do the same code. It just has to be indented as a block of the function block. Okay? And at the end, I'm going to return estimate and the error. So the way I execute this is I actually decided to turn off printing from within the function and print from the outside just to test that I grabbed the numbers correctly. And I say Monte Carlo pi of 100 this time, and my estimate is 3.32 and 5% error. Some of you have been pushing to 1,000. We can do that. That takes a little more, but my error goes below 1%. This here actually begins to be the key of numerical methods. To test that your numerical method is getting better and better with resolution. In this case, number of points n is basically testing what we call convergence of the method. And you're supposed to get better and better accuracy the more resources you use, essentially. And you kind of test how this error behaves. I'm going to do this actually. So I'm going to actually put this inside a for loop for I in range, or I can just give myself numbers. So I'm going to do 100, 400, 1,000. Okay? And I'm going to say for I in A. So these are my testing number points. I'm going to execute this. And I'm going to also say n equals to well, in this case, I'm going to call it n so that we're the same. So hopefully, as I go from 100 to 400 to 1,000, I'm going to see error go down. Okay. Only for 3 values, you can do for more. Shall we push for 2,000? Let's. It's going to be a little longer. Okay. You can see how it takes a little longer. A little longer. So I am getting better and better, and my error is getting lower and lower. This is a sign of a good algorithm, good numerical method. Questions? So do you see how this enabled me to properly study by packaging this as a function that I'm going to execute multiple times, instead of having that entire code of Monte Carlo here. Eh? That's clumsy. Everything is just parameterized with n, right? And for 2,000, it gets pretty. That's now a proper circle. Remember what we started with 20? That didn't look like anything. There was like 2 points outside of the range.
Where did you put 2,000?
I executed this for 2,000.
Okay.
But I executed it for 100, 400,000, 2,000, so this got better and better, the plot. So this is why we need functions, to be quicker and more efficient. Right? The only thing, I don't need to know what the details of the code are. I just need to know that it works at some point, right?
Could I see what you did before?
This one?
No, like even further back.
So I took the entire code that we had here in the previous cell, and I indented it. And basically what I add at the beginning is definition of a function. Everything is now indented, and there is a return at the end. And return returns the values that I need. Everything else inside the function stays in the function. Okay? So if I want to print now x or y or whatever the points are, I don't have that anymore. If I want it, I need to pass it out of the function. So it has to be a function output. Otherwise, it stays there. Remember my kitchen in Vegas, whatever applies to you? That's what goes to Vegas, stays in Vegas. In my case, I haven't been to Vegas, but whenever I cook, I like leaving all the mess behind in my kitchen. And what goes out to the dining room is just the final result. Yeah? Okay. That wraps up functions. One final note is that if you actually, especially if you define not just one function, but multiple, if I wanted to do this to be a module that I send to a friend, all I will do is output this code as Monte Carlo py Python. So Python, not notebook. Okay? And I send it to someone. And the way I import it in my code, some other code, I just say import Monte Carlo Pi as whatever it is that I want to name it. Yes? So whatever code you make, you can output it as Python py file, pure Python, no notebooks. Okay? And you can import it into any other code and start using it as if it was inside. Other than that, functions can be defined anywhere in the code, in the middle of the blue. They don't have to be strictly at the beginning or strictly at the end of the file. They can be anywhere in the file, and you can just start using them immediately. Okay? This is essentially these lectures 1, 2, and 3 of what's going to be included on the test. Okay? So I typically include the material that finishes 1 week before the exam, so we have some time to recap. Okay? I'm going to send more details, but essentially, on the test, you will have lectures 1, 2, and 3. Okay? Yes, you will get a cheat sheet. Okay, so I'm going to commented.
I didn't know if you said anything about it or not.
Throughout this, so you basically get 1 or 2 pages. I'm not strict about it because people have different handwriting of notes that you want to use on the exam. The only thing I don't want to see is fully solved problems. Okay? Everything else, like whatever definitions you need, goes. Front and back. Again, I'm not so picky about the number of sheets because again, I can write a whole lot of information on one sheet. But not everybody has the type of handwriting. And whatever you find useful, please put on the cheat sheet.
When are you going to upload?